Okay, so for one variable distribution, continuous distribution, so we need one variable integration. So if we have two variables, we need a double integration, right? If we have a three variable, we will have triple integration. So as we know, double integration, triple integration, those things is too complicated sometimes, right? So if we have many variables, then we have a big trouble. Okay. So if we have many variables, we can only some typical situation. So here, let's say typical situation is like we just find minimum smallest one or maximum largest one. So those in statistics we call order statistics. Order statistics. The smallest one, largest one. Then we can, in general, we can consider like let's say that we denote this smallest one. Suppose we have n variables, so we denote this as one n is minimum one. So among n, the first one. So maximum one, we denote this as usually x n n. Among n's largest one. Suppose we just x1, we just make this like a order one, right? So x1, x2, xn last. So here, if we say x1 is less than x2, so less than xn. Okay. So and in general, we have this x among n k among n the case or case one. So those are all the statistics. So from here we can say all the statistics is quite tough. So we have many researches and many problems involve all the statistics. Okay. So but anyway, like all the statistics is tough question. Okay. Okay. So now let's consider just the minimum. We just check minimum and maximum. Okay, so minimum, let's say maximum, so we have x1, x2, xn, have those, so we let y is maximum and z is minimum. So we want to find the distribution for those things. So how can find that? So for maximum minimum we have a way because we have this like for their cumulative function, like we say y less than x, so maximum of them the largest one less than x. This means each one is less than x. Okay, so here we assume those x1, x2, those things are independent. Then this one is, let's say this equal like maximum one less than x means this one first one less than x, second one also less than x, and xn less than x. So if they are independent, then we can change the probability is the product of each of them, right? So for each one, we know those function. Then we can find the function, and then we can have the density function. Use derivative, right? Mm. Okay, so for minimum, so minimum smallest one larger than this x, so means each one larger than x, right? Okay, right. So we can have such a problem like suppose let x1, x2, x3, we have three. So those things follow exponential distribution with mean is 1, 2, and 3. So exponential distribution, let's say x follow exponential distribution. So with the parameter lambda, meaning we say its density function is thus is lambda is negative lambda x. Okay. So we have thus like the expectation for x is 1 over lambda. Okay. Okay, so we have this result. So here we say if we know means 1 to 3, then lambda is 1 or 1 over 2 or 1 over 3. So now let's say suppose we let y is maximum or z is minimum. We want to find their density function. So in order to find the density function, we want to find thus cumulative distribution function. So this we define thus, right? This is probability of this variable less than y. Okay. So this y is maximum. So largest one less than this number. So means each of them less than this number, right? So each of them. So this means x1 less than y, x2 less than y, x3 less than y, right? So here we should mention this x1, x2, x3 are independent. Usually independent. If they're dependent, then there's such a problem. Such a problem is too complicated. Okay. So if they're independent, so we have this, right? So equal x1 less than y multiplied p x2 less than y, x3 less than y. So for exponential distribution, these functions easy. Suppose we just check this. Okay, suppose x follow exponential distribution with parameter lambda. This means the density function is thus, right? If x equal lambda is negative lambda x. Okay, so for those x, so we have this probability this x less than a. So less than a. So equal. So we say less than a is just from 0 to a. So here exponential distribution is just from 0 to infinity. So and this is the function. Okay, is x. So use substitution, like we just let lambda x. I'm sorry. We just let this lambda x equal t. So this equal, or maybe you can put a negative t, like a negative lambda x equal t. So this equal like t. Then we just changing everything to t, right? So dx is like lambda 1 over lambda dt, or negative, right? And then t from 0 to negative lambda a. So negative lambda a to 0, like that, right? And so we have lambda here, yeah. So lambda cancelled. So, but anyway, like by integration, so we know this equal 1 minus e negative lambda a. Okay. 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 So let's say, uh, so for this y, since x1, x2, x3, the mean is 1, 2, 3. So lambda is 1 over 1, 1 over 2, 1 over 3, right? So we can find this first one, x1 less than y. So we go back to here, okay? So we put it to here. So there's probability 1 minus e negative lambda. Lambda is 1, so just the y. Okay, so integration is just from 0 to y, right? And this one is 1 minus e lambda is half y. And this lambda is 1 over 3y. Okay. Okay. So these functions, y is cumulative function is thus. Then density function is just equals this function derivative. Okay. So for minimum, we should use, we just check, let's say, for minimum, we should check this. Okay, we just check large. Okay, so let's say, do we have space here a little bit? Okay, so let's say we just check f z. Okay, so this equal, we say the probability for z. We just check larger than. Okay, so larger than z. Larger than z, so this become 1 minus. Okay, so larger than z, so means smallest one larger than z, that means x1 larger than z, x2 larger than z, x3 larger than z. So for x1 larger than z, so larger than z is with less than z is we know less than z is 1 minus e negative lambda a. So larger than a is just e negative lambda a. So this equal e negative lambda. First one, e negative lambda is 1, so just lambda is 1, so e negative z, so this equal e negative half z, and this is negative 1 over 3z. So this case is easy. We can put them together, right? So this equal negative 1 plus, just like this, 1 plus half plus 1 over 3 z. So this is still an exponential function with just the lambda mean becomes 1. Means lambda is just this 1 plus half plus 1 over 3. Okay. Okay, so from this example, we can see such a problem like consider maximum, minimum. Maybe we can only consider exponential distribution because those distributions integration is simple. So for other case like for other distribution, saying this integration problem become tough. But anyway, like this is the idea. The idea is this, right? Idea is we just check a maximum. If maximum less than this number a, then each one should be less than a, right? So for minimum, if minimum larger than this number, so this means smallest larger than number, or smallest one is larger than this number. This means each one should be larger than this number, right? So this is basic idea. Okay. Okay. So as application, let's check this problem. Like we so let's say suppose we have 3 claim happen. So we want to find what is the expected value of the largest of these 3 claim. So we just check the largest claim of these 3 claim. So this is just a maximum. We just check maximum. We just consider maximum claims expectation. So we will so such a problem is just like that. Like we want to find y. So this y is maximum of x1, x2, x3. Okay. Okay, so in order to find y, we need to know its density function. Like y, according to definition, just equal y if y dy, right? And y, so just check all possible value for y from negative infinity to positive infinity. So here we need to find density function of y. So in order to find the density function of y, okay, maybe we also here maybe we also can use this like substitution or use integration by parts. This if y divided by we can change this as d if y. Okay, so this equal y if y, so minus if y dy. Okay. Can we do this? Let's see. If y. Oh, maybe we cannot use this because, like, let's say, so here problems. We okay. So usually we have trouble here because, like, when y is the largest y, then if largest y is 1, right? We say if infinity equal 1 or the largest point of 1 because if the cumulative probability is from 0 to 1, right? So, okay. But maybe this one not always works. Sometimes it works. So let's focus on this. So this one we need to find the density function first. So for such a problem we say what is so we just check this. But anyway we need to check this. What is if y less than? Oh, I'm sorry, notation. We just check this if y. Yeah. If y is this probability for y less than y, so this equal so y is largest one. So largest one less than this y means each one x1 less than y, x2 less than y, each one less than y. Okay, so each one less than this y equal like x1 less than y, x2 less than y. This is probability, right? And x3 less than y. So here x1, x2, x3 is from the same distribution. So we call those identically distributed or identical distribution. Basically, they are same thing. Like here, we say x is this claim, this x, this claim. Claim is a landing variable, right? So claim can be 1. So here, then the function can be 1 to infinity, right? So at least 1. Claim the loss, suppose 1 means 1,000. So each claim at least 1,000, right? So less than 1, the company will, insurance company will not deal with those claims. So x, so we can put this x larger than 1 to infinity. And the density function is thus. Okay, so we can find those probability, right? So each probability. So and by the way, there's 3 probability same. So we can say we simply can put this x less than y 3's power, right? Because that's same. So x less than y. So this is no. So here x less than variable, yeah, uppercase x less than y. So there's a probability. So we just go back to here to find. So there's a probability x less than y. So here's 0, but start from 1. So y is here. Okay, x less than y is this part. So x less than y. There's a probability actually is from 1 to y, right? Saying this density function dx. Okay. So this integration is okay, like because density function equal just the 3x negative 4. 3x negative 4. So if we integrate out, so this is x negative 3, right? It's under derivative equal negative 3. So let's go back to here, put it to here. Okay. So this integration is 3. This is x. So this is just the x negative 3. So this is just equal 1 minus 1 over y 3, right? Okay. Yeah, but because of the integrated out is x negative 3. Yeah. Okay. So 1 minus 1 over y 3. So here, so we say this equal 1 minus 1 over y 3's power. Okay. So here this y, so at least larger than 1, right? Because x larger than 1, so y larger than 1. Saying density function, density function about y, so equal this derivative, right? This thing's derivative. So equal 3 this square thing inside derivative. So y negative 1 derivative y negative 2, right? Okay, so like that. Okay, so now we can find the expected value. So expectation like y. So this is just become math problem. So this equal y. This density function dy. and y from 1 to infinity. So this becomes this integration, right? So 1 infinity. Okay, so y times 3 1 minus 1 over y square 1 over y square dy. So this become a integration problem. Okay. 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 So those are just the maximum, minimum. So for the thing we can have. Once we know this, so this one or such a problem is we need to find a maximum density function and then find the expected value. Okay. Okay, so here is also maximum loss, right? So this problem quite the same because they are exponential distribution. Okay, so those problems just involve lots of mathematics. Yeah, so integration. Okay, so now let's check this problem, variable transformation. So for discrete situation, such a problem may be easy. Like we have x for this distribution. Then we have a new variable y equal 2x plus 1. So we want to find this distribution. Y is distribution. So such a problem we say is okay, like easy. Like the y could be, so x could be 4, so y could be 9, right? And the probability is y equal 9 is just like x equal 1, so probability 0.1. And so x can be 3, so y can be 7, right? So probability is just the same as x equals 3. And x equal 2, so y can be 5, and the probability is thus. And x equal 1, so y can be 3, so probability is thus. So this is the distribution for y. So such a problem is very easy. So we say, so for discrete situation, variable transformation is not a big issue, easy. But for continuous distribution, so we're talking about, we focus on density function. So we have x density function, and then we need to find a y density function. So the y is y is the function of x. Y is transformed from x. Okay, so this idea is actually easy. Like we have a density function for x. We just changing all x into y. So we just changing this function. We just change x to y. So x change x to y. So we say x from here. We can say we can find x equal g inverse of y. So we just replace this x by y. So g inverse y. Right? Replace x by y. But we also need changing every. We also need to do this because for integration we have dx. If you use variable transformation or variables substitution, you need, if we change x to y, you need to change the function to y in terms of y, right? Function for x change to function for y, and you also need to change dx to dy. So from dx to dy, so let's say from before dx, but by now we focus on dy. So from dx to dy, actually we can say dx equal this multiply dy, right? Okay, so we need to multiply this factor. So dx over dy. So the dx over dy is just the derivative of y. We regard x as a function. Okay, so once we understand this thing, so transformation is easy. So let's say like here we have x has this density function. So this actually is x for exponential distribution, so lambda equal 2, right? But anyway, like we want to find, so we use substitute. We have a new variable y. This y equal x squared. So we want to find the density function of y. So at the first we just changing this. So we just changing this x in terms of y. So keep it as a 2. So negative 2. So changing x to y. So relationship between y and x is y equal x squared. Okay, so we can say this x equal like radical y, or half y half. So positive negative. So we, because x is positive, so we just check positive. So this is x is just radical y, right? Then don't forget this dx over dy. Multiply this. So dx over dy. So what is dx over dy? So this is just this function derivative regard y, right? So this derivative is just equal y half the power, right? Half the power derivative, so we know this equal half, then half minus 1, right? Just the x alpha, the derivative equal alpha x alpha minus 1. So we have this density function is this, right? Okay. So such a problem actually is not so hard, easy. Okay. So here we know there's t has this not a density function, just cumulative distribution function. We want to determine this y's density function. Okay. Okay. So we can say like we can we can find the density function of t, right? So density function of t is 2. It's a derivative, right? 2 over t. Like x squared is derivative of 2x, then is derivative. So 2 over t is derivative. Okay. So here just a little bit of calculation. 2 to 4 over t. Let's say 4 over t. There's a derivative of 2. Okay, the t negative 1. Negative 1 is negative 1, negative 2. Yeah, so 2. Okay, so t larger than 2. Yeah. Okay, so this is just the density function. So density function y. So we just changing this y equal t square. We just replace t square as t square as y, right? The t3 is y 3/2. Okay, and then don't forget this dt over dy. Okay, so dt over dy. So here we just say t equal y's half. Okay, so this equal just 8 y 3/2, saying this derivative half y negative half. Then a little bit simplify this equal 4 over y 2, right? Okay. Okay. So this is, let's say, this is a variable transformation. So idea is just that from density function, we just changing the variable from x to y. Then don't forget we should change dx to dy, right? So we should multiply dx over dy or its derivative. Okay. Okay. So such a problem part is the same. Okay. So we have R's distribution. So R is uniform distribution, meaning like this is a constant on this term constant. And then V is new variable, so we want to find cumulative distribution function Fy or Fv. So those problems is Fv cumulative function is this probability V less than V. So what is V? V equals this. So that's equal V equal this R less than V, right? So we just change this in terms of R. So that's equal R less than V over 1 or 10,000. Okay? And then we also need to change it to R. So this equal like R less than log, right? Log V over 1 or 10,000. Okay? So R less than this, so this means this probability, so this probability is the same. So R follow uniform distribution. R means constant from 004 to 008. This uniform distribution constant. Then we want to find this probability R less than this number. So this equal log V over 10,000. So this probability, so because this is this is a uniform distribution, so this probability is this part count for how much for all. So all is we just check this things. 008 minus 004 is 004, right? The total length is this. Then this part is just ln this number minus, okay? So this is the cumulative function. Okay. Okay, so such a problem I just leave for you. We want to find a density function. So we have x. So x is exponential. Yeah, we have this x. Then we want to find. So we know x is density function is like a, let's say in general is lambda is negative lambda x. So here means 1, so lambda equal 1, so this just equal negative x, and x larger than 0. So this, so we have the density function for x. Then we want to find the density function for y. So we just change this x to y. Then don't forget dx dy, right? Such a problem should be easy. Okay, and so here we're talking about like those things that are the continuous distribution, right? So we also have the mixed distribution. We put a discrete distribution and continuous distribution. So sometimes like those problems could be confused. Okay, so at the first let's review. If x has this x the discrete distribution, x can be 0, 1. Then we want to find the cumulative distribution function. So x can be 0, can be 1, and the probability x equals 0 is 0.3, and this is 0.7. So cumulative function is, let's say, cumulative function f x is, according to definition, is this probability x less than this x. Okay, so we check like when x, so here 0, 1. So when x is less than 0, x here, so x, this part probability 0, right? And x equal like so we can put this case, if x less than 0, this probability 0, right? So if x is a little bit larger than 0, include this 0, like x equal 0.1. So x less than 0.1 include 1 point. So there's probability 0.3, right? So when x larger than 0 or equal 0, but less than 1, right? Now x a little bit, x between 0 to 1. So if x is good to here larger than 1, then says probability x less than like suppose this x 1.1, x less than 1.1, so such a probability is 1 always, right? Because this x can be only 0 or 1. Okay, so for graph, so graph is just like that. Here is, let's say 0, 1. So here's 0, then jump to 0.3, right? 0.3, 0.3, then jump to 1. Okay? Okay, so when x equal 1, so we put this as a solid circle point, meaning when x equal 1, function y equal 1. So not this, not this negative, not this 0.3. So here the solid, and here circle, right? So here we can say like the jump function. We also can say like the jump function, the jump, jump, jump. Okay. Okay. So here this x has this tensor function. X equals 0 is 0.5. X equals 0 is okay. So we put the function 0.5, and when x between 1 to 2, this function x minus 1. So here's x equals 0. When x equals 1, the function is 0. When x equals 2, 1. Okay, so the graph like that. Okay, so here we say like this is continuous part, continuous. This one is discrete situation, right? So such a density function, we say this is a mixed, combined, like some point is discrete, some is continuous. So this x can be 0 or can be any number between 1 and 2. Okay, so let's check this problem. Okay, we find this probability. So such a probability of x 1.5. So such a probability is equal x equals 0, 0.5. So plus so this part. Okay, so I think this part is just this integration. This part is I think is half. Like here's half. So this is just the area for this triangle. So half, half times half. So 1/8. I think like that. So this triangle area is half of this times this, right? So 0.5 plus 1/8. Okay. Okay, then find cumulative function. So cumulative function is like this. So when x is less than 0, so this is 0. Then when x equals 0, just jump to 0.5, right? Then from 0 to 1, so this probability is nothing happens. So this one, so no jump, just equal 0.5, right? Then from 1 to 2, the probability will go up, right? So go up until 1. So here's 1. Then when x larger than 2, so this is always 1. Larger than 2, so because x is like x less than 2, less than like 2.5 or 2.1, this probability is 1, right? So this is a cumulative function. So such a function we can say like this function is not continuous. We have a jump just continuous here, and this is a flat line, then increase continuous, then no increase, right? Just the horizontal line. Okay. Okay. So such a problem is not so hard, but we need understand those notation. Yeah. So that's the function. So this is just mixed, right? Mixed continuous and discrete. So we have such a problem. Let's say, like we have the cumulative function like that. Then find variance for x, or find expectation, right? Or find the density function. Okay. So from a cumulative function, find a density function. So if this function is continuous, so this is easy. We can use derivative, right? We can use derivative. Okay. but here this function is not continuous, cannot be used derivative. So in mathematics, so we call this as not differentiable, meaning this function you cannot use derivative. Okay. So for such a problem, we have to use definition. We have to use our understanding, right? So let's draw this graph. Okay. Okay. So this is when x less than 1, this is 0. Okay, 0. Then between 1 to 2, this function is this, like a second degree polynomial. So we just check when x equal 1, when x equal 1, so here point when x equal 1, this function is, let's say, 1 minus 2 plus 2 over 2, right? So this equal half or 0.5. So we say at this point we have a jump 0.5. Okay, so it's about this 0.5. So from 0 to jump to 0.5, and this is solid point, right? Jump to when x equal 1, jump to 0.5. Then here is this is just the second degree polynomial, just like that. So when x equal 2, I think this equal 1. Okay. So then when x larger than 1, this always 1. Okay. So for such a function, so for this cumulative function, so we know when x equals 0 or equal x1, they have jump. So this means, so we can find this density function is just like that. So when x equal 1, when x equal 1, probably 0.5. So when x between 1 to 2, so this part continues, so we can use derivative. So this is like a derivative, that 2x minus 2, right, over 2. So this is equal x minus 1. So this is just x minus 1. Okay, so then this derivative is 0. Okay, so this is a density function, should look like that. Okay, so we have this point 1, we have this part is jump. So we say more precisely, we can say this density function f(x) equal 0.5 when x equal 1. Okay, so when x larger than 1, between 1 and 2, then this is x minus 1. Okay, and when x larger than 2, this is just 0. Okay. Okay. Okay, so now if we understand this, then find the values of x. So is okay. So according to definition, like values of x equal x squared minus x squared, right? So we just do those calculations. So what is x squared? Let's check this. X squared, so equal, so x we just check it. Oh, we have x equal 1, so this equal x equal 1. So 1 square multiply the probability that x equal 1, which is 0.5. Okay, so this point we should check it typically. So then for x larger than 1, so this just equal x squared multiply its density function x minus 1, right? So dx. So when x, So for integration equal 1 or not equal 1, the same for continuous situation. Like so we say for continuous this continuous part. So just from 1 to the x squared. So they do this integration, right? So same way for x, x can be 1, so 0.5, right? And between 1 to 2, so this x minus 1 dx. Okay, so now we can find the values. Okay, so for discrete distribution, we have some typical distribution. We have typical discrete distribution like a binomial distribution and binomial distribution, like geometry distribution and Poisson distribution. Okay, so geometry distribution is just keep trying until you get one success. So if we can only stop until a success. Keep doing until a success. Then we have what we call this negative binomial distribution. So those are typical distribution, right? Okay. So for continuous distribution, we also have some typical distribution. Like most important is the normal distribution. Maybe we quite familiar with the normal distribution, right? Because in stats, many things, most of the things follow normal distribution. Okay. So from mathematical point of view, so distribution we just need a density function. We just need the density function. This function is positive, or and total integration equal 1. So those are density function. So we have many those functions. So typical function is we have this like polynomial function, or typically simply state the like a constant function from a to b. This is constant. So those distribution is we say uniform distribution, meaning it's like x can be any number from a to b, and the chance is same. X equals that point, x equals that point, the chance is the same. So this is a uniform distribution. And then for exponential distribution, so polynomial function from a to b we have this, or from a to b we have this polynomial function, right? Oh, we also can, yes, but such things, something follow polynomial distribution, such a thing is not so often, not very common. Okay, in real situation, maybe like this uniform distribution makes sense, right? So those things usually make no much sense. Okay, but exponential distribution, we say, some probability always goes down, right? Typically in our health condition, right? Or the probability for being health. So our health is goes down. So many things goes down. So goes down. We can use exponential distribution. So those functions like typically just negative x, right? Then changing a little bit, or maybe negative lambda x, and then make this integration equal 1. So we find this. We should put a coefficient as lambda, right? and the normal distribution goes down on both sides. So here goes down, here goes down, like that. So goes down smoothly, so cannot be goes down like this way, right? So it goes down smoothly. So let's see, so like that. So goes down smoothly. So such function just is negative x squared. So this negative x squared is just like a normal distribution. But for this negative x squared, so integration equal 1, so maybe we need to find the constant. Okay, so there's a constant. How can find this constant? So this become math problem. Yeah, but anyway, like basically, those for continuous distribution, those three are most important continuous distribution: uniform distribution, exponential distribution, and normal distribution. Okay. Okay, so we can stop here.